Physics 2212 Lab 2 was about the amount of excess charge on an ordinary object and was an extension of the first lab. The goal of this lab was to calculate the amount of excess charge on a charged piece of tape that we were tasked with creating. Additionally, this lab was an extension of Lab 1, and we were tasked with trying to create a more in-depth GlowScript model for the experiment. The results of the lab included that the U-tape I produced appeared to be positively charged, with a total excess charge on the tape being 1.82 times 10 to the negative 8 coulombs when calculated, and the magnitude of the electric force on the GlowScript model was 0.0282, and the magnitude of the gravitational force was 1.962 times 10 to the negative 3. There were multiple physics principles explored in this lab. This lab involved Coulomb's law, which discusses the magnitudes of electric forces and explains the relationship between how positive and negative charges react to one another. Another physics principle explored was superposition principle, which explains that the net force on an object is an accumulation of all of the forces on the object, and that the electric fields of the object are independent of one another. The last physics principle explored was the electric force equation. Similarly to Lab 1, this lab involved pulling a piece of tape off of a base tape to create a U-tape that had a charge, and then testing the tape against a multitude of objects to see the interaction. Then, holding one U-tape under another U-tape and measuring the distance it took to create a visible repel between the tape, we found the extra charge on the tape. Two assumptions were made in the experiment. The two assumptions that we made were that the pieces of tape have the same net charge and that the charges must be demonstrated as line charges. On this page, I've included all of the calculations from Lab 1. I calculated the excess charge on the piece of tape using the electric force formula. Because the tape was not moving, the net force must equal 0, making the electric force equal to -1 times the force of gravity. Using the force of gravity equals mass times acceleration due to gravity, you get the force of gravity and can plug that value into the electric force equation so that you get the charge on each piece of tape to equal 1.82 times 10 to the negative 8 coulombs. For the code, I needed to create a function for the electric field. I needed to input the experimental calculated values, such as the mass, and I needed to create the line charges of the top and bottom tape with their corresponding distance from one another. Additionally, I needed to adjust the scale and add arrows to represent the electric force on the top tape and the force of gravity. Lastly, I had to edit functions in order to make the electric force and the force of gravity and their correct calculations. This is what the code produced as my GlowScript model. The white arrow represents the electric force on the top tape. The yellow arrow represents the force of gravity on the top tape, and the green arrow represents the electric field across the top tape. In conclusion, similarly to Lab 1, the tape that I used appeared to have a positive charge based on its interactions with other objects. Additionally, in Lab 1, the gravitational force was calculated to equal 1.96 times 10 to the negative 3 newtons, and in Lab 2, it was calculated to equal 1.962 times 10 to the negative 3 newtons. This is a distance of 2 times 10 to the negative 6 newtons. In Lab 1, the electric force was created to be 1.96 times 10 to the negative 3 newtons, and in Lab 2, the GlowScript code calculated it to equal 2.82 times 10 to the negative 2 newtons, which is a difference of 2.62 times 10 to the negative 2 newtons.